this is by request. We're looking at some polynomial review, and we just want to start with something we learned in the first unit. Let me get my lights a little more ample there. More light, more light, more light. Hopefully that gets rid of all the shadow. So we covered polynomials in our first unit. Let me get a bigger marker. We need bold markers now. So we got a few colors. We got red, purple, and orange. We'll start with the orange problem. Or green problem. There we go. Anyway, so look at a polynomial here. Let's draw it in. We got 8p to the 6th power minus 5p cubed plus 2p squared minus 7. And I'm just taking your polynomials quiz. You can find this quiz on Google Classroom, of course. Pardon me. And you took this in end of January. So, well, let's analyze this polynomial. Let's look at its degree. Its degree, well, I'm going to look over here. I look at the highest power. It's right here. So my degree is 6. Or you can put 6th. Doesn't really matter if you had to TH. I don't care. Maybe some other schools do. Next, we'll talk about the number of terms. Well, we have 1, 2, 3, 4. So we have 4 terms, and they are separated by addition or subtraction. You can see that there, yeah. All right, good. What else do we know? Look at the leading coefficient next. I'm going to abbreviate that as coef. Leading coefficient, that would be 8. Because it's the constant here. It's the constant multiplied to highest power or degree. Well, let's use power here. Exponent, etc., etc. And one last thing, we'll talk about end behavior here. Pardon me. I have some bad allergies today. All right, so this end behavior will be up and up. Let's use a different color to change things up here, up and up. Okay, so that's how we look at the polynomial review. Now, how do I know it's up and up? Well, remember that you have these charts that we look at here. So this is an even degree, and it's a positive leading coefficient. So we would expect it to have, if this was our x and y chart here, we would expect it to have a shape some degree like this. Though we don't know the exact shape, I think actually it'll probably have more of a few humps there, like a W shaped. But you get the point. It's still going to start up and finish up. So that's why you could also write it like this. That's the first part of polynomials we want to review. Let's go next now. That was just the first section. Okay, here. Let's go number 2 now. Factor. So at number 2, we want to polynom factoring. Let's start with the easier ones. We're talking about quadratics, right? That's what we learned in Algebra 1, so we'll start there with a little review. We have x squared minus 3x minus 18. So, of course, this equals 0. Now, how would we factor this? Well, we simply make our little cross eye here, and we have to ask ourselves, remember the form that all polynomials, all quadratics take this form of ax squared plus bx plus c equals 0. And then if we look at this, we see that our b term is going to be, let me put this someplace off to the side. Well, a is going to be 1, because there's a 1 in front of here. We can write it for those of you who need to see it. There you go. Our b is negative 3. And our c in this case would be negative 18. Do not forget those negatives. They're really important. So, what do we need here? We need two numbers. We need two numbers that multiply to a times c. So a times c here is going to be 1 times negative 18, so it's negative 18. We need two numbers, I'll put it here. Two numbers multiply negative 18, but add to b. Well, b is negative 3. Okay, so let's generate a few possibilities. How about, let's do positive 6 and negative 3. Well, that multiplies the negative 18, but it doesn't add to negative 3, does it? So, but I think I'm really close, because these two add to positive 3. So let's try negative 6 and positive, pardon me, I'll put a little plus sign there, positive 3. Now these two make it, so then I can rewrite this quadratic as x minus 6 parentheses times x plus 3 equals 0. This also gives me the zeros, or the roots of this, right? The roots or zeros, I don't know why there's two different names for the same thing, but they are. So the roots are the zeros here. Pardon me. Well, in this case, we look at what value of x, or let me just treat each one independently. I have two ways to reach a 0. I have the orange way, and I have the purple way. So the orange way, I write it just as itself. It's x minus 6 equals 0. And then I can just solve. So one of my roots is going to be 6, because x equals 6 in this scenario. Let's take the purple scenario now. This is x plus 3. Oh, jeez. Equals 0. I subtract 3 from both sides. Arrow. That means that x equals minus 3. So that's my other root. You see how to find roots. By the way, I could also graph this. You should be able to graph it too. So I have, well, I know this is a quadratic, so it's going to have this kind of, it's kind of this U shape, because I know it's a even exponent, and it has a positive leading coefficient, so I'm going to have this U shape, and I know where it crosses the x-axis, right? These are also known as, again, another name, x-intercepts. Don't blame me, I didn't make all the different names up. So, 1, 2, 3, 4, 5, 6. That's one. This place is going to crash through. We have here 1, 2, 3, negative 3. So my chart's going to kind of look like this. No one needs to be perfect, but that's the basic shape of my parabola there. But there's different levels, of course. I'm going to run out. Hopefully I don't take this video too long. Different levels of polynomial knowledge, so let's go to the next part. So we also covered in class was what happens if we have to factor a quadratic that has, you know, a number in front of it. Well, no problem. We just use this form. Get that light fixed. There we go. I should fix the shadow a little bit. There we go. So this equals 20. Doesn't matter. We still use our crosshairs method. It's a times c. That's 5 times 20. We need two numbers that multiply to 100, but add to 29. And you can mess around a little bit. Let's try 5 and 20. Well, that does multiply to 100, but it doesn't add to 29. So nope. Let's try 25 times 4. And obviously this one does work. So I can rewrite this equation as, but before I move on, hold on. Just know that sometimes it takes more than 2 times. It can take you 3 times. You just keep going through different multiples until you get a hit. First 2 multiples that multiply to 100 but added 29. You won't always get it in 1 step, 2 steps. Sometimes it takes you 3, 4 steps, but you'll get faster at it each time you try. So let's write this. Now I know my 5x squared is here. Do I want to write the 4x with the 5x squared, or do I want to write the 25x? Well, I think 25x is a better fit because they both have a common factor. So I want to group these together. This is factor by grouping. Is the name you can search for it on the internet. It's factor by grouping there. There it goes. So that's here. And this is my 4x goes here because it's a better fit with the 20. Now this comes from experience. You won't always know to do this right away, but the more you do it, you will get better at it. So here, notice how these two still add to 29x. See, I didn't change anything. They're still equal. I can do that. Now let's factor the first section here. Ignore that one on top. So let's pull out the greatest common factor. That's 5x. So I know that 5x times x is 5x squared. And let's look over here. If I divide 25x by 5x, I just get 5. Let's also do the next section. Let's use purple. Let's use a different color. Let's use red. Hopefully that change. Will you be able to tell the difference? Probably not. So let's use brown. Okay, so let's pull out the greatest common factor here. And I'm going to pull out 4. And I get here x, because that's 4 times x, and it's going to be 5. And notice it's a coincidence, it's not, that these are the same, if you did it right. So now let's pull this out of both numbers. We get x plus 5 is now removed, and what's left over? It's going to be 5x plus 4 equals 0. And here again, you can find the zeros in each case. You can take the orange form. There are 2 different ways to reach 0. So it's going to be x plus 5 equals 0. That means x equals negative 5. This is a root, or a 0. We have the other method, or let's do the purple here. And we have here 5x plus 4 equals 0. I subtract the 4 from both sides. Here we go, and I get that 5x equals negative 4. You can see that hopefully. There it is, and then I divide both sides by 5. The other root is going to be x equals negative 4/5. So that's my other root. So you should be able to do these like that. Let's look at a more advanced factoring now. Something where we have to use synthetic. We're going to teach you now. We're going to look at synthetic division. Another sheet of paper here. I won't pull out my whole bookshelf at the same time. Hopefully not. There we go. So we have more paper here. And let's take a look at, we have x cubed minus 5x squared. And we're going to teach synthetic division here too. So now what happens, you want to be able to find a root for this. This was an extra credit problem, but it's going to teach us a lot at the same time. So they want us to factor this completely. Well, how do I know what the roots are? Well, there's actually an old theorem. If you look over here, we know that all possible, this is called the rational root theorem, right? Rational root theorem, also called the rat theorem. So the rational root theorem states that all possible roots are factors of, it can be found from the factors of the last term divided by the factors of the first term, or the constants. So this is a 1 here, just by the way, don't forget that. So, well, let's look at 5. So 5 is our last term. What are our possible roots, what are our possible factors of 5? Let's write that properly. Factors of 5, go on top. And let's get the factors of 1. That's easy. We always love to get 1 in this scenario. So it's going to be plus or minus 1 are all my factors of 1. And this is going to be plus or minus 1 as well. That's a factor of 5. Also, plus and minus 5. So all my possible factors are going to be 1, negative 1. Probably can't see that. Let's write that down here. Are going to be 1, negative 1, 5, negative 5. So let's check out here. I happen to know that 5 is a root, but you might have had to do synthetic division on a few others to find out. Let's show how we do this. Let's do synthetic division here. So we have our original equation. It's going to be, so this is a 1, a negative 5. It's a negative 1 and a 5. And I'm going to say, let's test out this root 5. So I put a 5 here. Okay, I bring the 1 down. And I do 5 times 1. That's 5. These two add now. And this gets a 0. 5 times 0, well, that's 0. Get a negative 1 comes down. They add them. 5 times negative 5, that's negative 5. I get a 0. So this is a root. It is. Because I get a remainder of 0. This is my remainder. That's good. So then this means that this thing equals x minus 5. Because remember, 5 is a root. Looks like an S. There we go. 5 is a root. And what's left over? Well, this is going to be x squared. And this is going to be 0x. It's going to be minus 1, so I can write it like this. I don't have to write the 0x, so it's going to be x squared minus 1. And that's mostly factored there. You can even factor it just one more step if you like. And I won't show that one here. This becomes x minus 5 times x plus 1 times x minus 1. You can see that there. Okay. Almost out of time here. I think we're going to... So let's look at... That was synthetic division. That's how you can test and see roots there. And I want to make sure I covered everything from the polynomials that we did. We covered how to graph, but I guess we can cover it again if you like. Here. I think we covered rational root theorem, covered synthetic division. All right, let's cover a more advanced graph just to wrap it up. And I'm going to the... This video is running too long, I think, for YouTube standards, but hopefully you can just, speed me up or skip around, whatever you need to do. So let's look at this one. This was problem 6 from the polynomial quiz. This was f of x. Suppose you had a function that was 3x cubed plus 24x squared plus 45x. Now, how would you deal with this? You want to graph this. You have to factor it first. So to factor this, we pull out the greatest common factor, the GCF. Let's switch to orange here. So our greatest common factor is 3x. Here, so I pull 3x out of that. I get x squared is left over. I get an 8x squared is here. I get a 15. There we go. So I can then factor this out by doing my little cross-eyed trick, can I? I need two numbers that multiply to 15, but add to 8. Oh, don't you mean 5 and 3? So I can even write this again. Let's draw it down here. It's going to be 3x, x plus 5, x plus 3. Now, what are my roots or my zeros? Well, I have 3 different ways to get to 0. See, this way, that way, and I've covered that before. So my roots are, these are my x-intercepts, right? Same thing. It's going to be 0 from here, negative 5 here, negative 3 there. So I come over here and graph this. Let's look at my function. I have an odd function, and I have a positive leading coefficient. So I'm going to have this loop-de-loop structure, like so. And where does it cross the x-axis? Well, I know that. It crosses at 0. It crosses at negative 5. Let's count 1, 2, 3, 4, 5. Not perfect. And at negative 3. It's going to be kind of a little difficult to draw, but you get the point. I don't know how high up and how... You don't really know about how high these humps go. That's chaos. You can check a course of a graph officially, but that's why we don't have the unpredictability. So that was a review of all the polynomial stuff I taught you in the first unit. You're ready to take the review or the retest on quizzes if you did well in this video. Thanks and have a great weekend. This is Mr. Chair's Algebra 2 class, signing out.